everyone. Thank you to join me in this session about open telemetry, chaos engineering, metrics, and all these fantastic topics. But before to start, allow me to thank you to our sponsor that allows us to be here and to follow this session. So many thanks to all these sponsors. And go on in this presentation. In this presentation, we are going to see some topics, starting from observability, because before to improve any system, we need to know something about the system. And when you talk about observability, nowadays the standard is open telemetry. So we have a look to open telemetry and how .NET Aspire, this new .NET framework, introduced and allows us to use open telemetry. Finally, we can talk about distributed system and relative fallacies of distributed system, and how chaos engineering helps us to resolve the problem or the fallacy of distributed systems. So go. Observability. When I introduce the topic of observability to someone, I like to use this definition by Charity Majors that says observability is about understanding and debugging unknowns. That I love because that means that observability is the ability to understand and any inner state of our systems. And it is good because we need to measure any state of our application before to introduce some improvement. And the standard factor nowadays of observability is OpenTelemetry. OpenTelemetry is a protocol, is an observability framework that has as a great advantage the fact that it is vendor and tool agnostic. And this is very great because we can use open telemetry in all our application, no matter what is the language or the framework that we use, because it's independent. Open telemetry is independent. It's focused on collecting and management data from application, and it provides to us a lot of SDKs in many different languages and frameworks, so we can easily introduce open telemetry inside our systems through these fantastic SDKs. Another when we collect our metrics, our logs from the application, after we have collected this measurement, we need to show these data in an easy way. And we have discovered how to do this. Three pillars are the characteristics of observability, or three signals we can use when we talk about observability. The first one is metrics are measured to say to inform us about the latency or the rates, error rates, or saturation data in our application, and we can acquire all this data from our device, from our services. Then we have traces. Traces is a step-by-step approach, and through traces we have specific information about performing or problems in specific services or in specific components in our application. And last but not least, we have logs. Logs because everything that happens in our application, and we can register all these logs and then analyze logs to understand why and something happens and the environment around this situation in our application. But how we can introduce observability in our .NET application? Because, as I said, OpenTelemetry provides a lot of SDKs. One of these is for .NET, and so we can reference OpenTelemetry directly in our code through an SDK provided for .NET. But also we can, using an out-of-process approach, using, for example, .NET monitors, using even Py tools such as .NET Monitor to an out-of-process access to our measurement. Last, also we can inject assembly inside our application, like OpenTelemetry.NET automatic instrumentation, and having the same result in our approaches to the OpenTelemetry. After we have collected the information, the measurement from our application, we need to observe, to visualize all this information. So before we need to collect this information in a database, in a store. One tool that we can use to solve this task is Prometheus. Prometheus is an open source project, CNCF graduate, totally open source, 100% open source, used for event monitoring. That means that it records metrics and it collects all these metrics, store all these metrics in a serious database. And his approach is very interesting because it uses an HTTP pull model to collect, to provide data from our application and stores this data inside the serious database. Then, once we have collected all this data inside Prometheus, we can use, for example, Grafana, or Grafana is not the only tool, the only tool that we can use, but Grafana is open source, so I like open source. And the goal of Grafana is to visualize the data that we collected through Prometheus, for example, through the diagrams and charts. And it provides to us many dashboards that we can build or we can import from another situation, from other vendors to visualize the situation of the measurement that we acquire from our application. But it's demo time, the first demo time, and so how we can introduce OpenTelemetry inside our application. Because OpenTelemetry provides a lot of SDK, we need SDK also for the our .NET project, and we can add some important NuGet package to our application with the name OpenTelemetry. So we have OpenTelemetry instrumentation HTTP, ASP.NET Core, and many other like OpenTelemetry protocol, because I said OpenTelemetry is a independent tools, and we need also hosting and many other tools. To add OpenTelemetry to our application, we simply add OpenTelemetry to our services collection when we start up our application. So the only thing that's important to do is this line of code, add OpenTelemetry. After this, we can add to OpenTelemetry some metrics, but because ASP.NET Core provides as a lot of built-in metrics inside it, we can simply indicate what is the metric that we need to add to our application. In this case, I added just 2 metrics, but we can add many metrics to our application, to your application. Because OpenTelemetry export the measurement to the other tools like Prometheus, we need to add also the package Prometheus exporter that allow our application to expose data and allow OpenTelemetry to receive data from our application. But OpenTelemetry doesn't receive data from our application. Our application exposes data through an endpoint, so we need to add this line of code, map Prometheus endpoint, that expose an HTTP endpoint under the common root/metrics, and Prometheus, using its HTTP pool model, can absorb information metrics measurement from our application and collect inside its database. After creating all these in our application, we can instantiate an Prometheus server using Docker Compose. I provide all the code and the Docker Compose that you need to run by itself, by yourself, the demo at the end of the presentation. We can run a Prometheus service, and as you can see, this is, sorry, you can see, yeah, okay. You can run Prometheus service. This is how we dispose some endpoints. For example, we can sales order, and this is the target of data that our application sends to endpoint. When after we have collected all this data, we can use, for example, Grafana. So I create a Grafana installation on my PC to Docker, and with some dashboard to visualize all the necessary endpoint and the chart that describes us the situation of our application. Now we can move to your Swagger, for example, interfaces, and put F5 on your keyboard to create endpoint request to your application to test your application. Or you can use a fantastic tools, for example, Locust, that is a load testing tool that allow us to create millions of simultaneous users to use our application without press F5. To create a Locust experiment, Locust test, you need to write some simple code of Python that invoke, for example, this endpoint, v1 sales, and run Locust. Once you run Locust server, it exposes an endpoint to us. This is the endpoint, localhost 8089. And moving to this endpoint, this one, you can create, for example, an experiment with 1,000 of users and a ramp up of 100 users for seconds. And sorry, and for example, and start our experiment. Starting the experiment and moving to the chart paragraph, we can say all the requests that our application are sending to our system, and in green we have a peak and a degree and peak again. In green we can say all the requests that has success, and in red the request that fails, and in the meantime, our application are sending all this information to our system, to our Prometheus that collect information for us, and through Grafana, we can move to one dashboard to another one and see that we have a number of HTTP requests on sales. All these requests are green, so are successful request, or for example, you can move to another dashboard, and we can see that till now we have more than 500,000 requests, because I ran the test before to start in the session. All these the requests are green, so are successful without exception, and so on. And we have a lot of information through dashboard provided by Grafana. Because it's not so simple create a Grafana dashboard, the Grafana teams provides to us some fantastic dashboard, pre-built dashboard that you can find on Grafana website under the .NET team, that provide to us two dashboard, I said, and it's easy to use this dashboard inside our Grafana installation, because if you move to details, you can copy the ID of this dashboard. This is the simplest way to import the Grafana dashboard, and then move to your Grafana on dashboard. Then under the new menu, you can click import, then paste your ID in the relative section, then press load to have these two dashboard that I imported before. And this is the same board. You can check from this number that Grafana provide to us to import to prepare this dashboard. Okay. It's not so impossible or difficult to have observability in our .NET application, but so far we need to know how to write code in .NET, how to use OpenTelemetry, for example, how to use and set up Grafana to display all the information. That means a lot of things that developers you have to know to using to have OpenTelemetry observability in your application. In the last period, the last years, the .NET team developed .NET Aspire, a framework that helped us to create a distributed application for the cloud. But not only to create from scratch new application, you can add .NET Aspire also in an existing application. And adding .NET Aspire to an existing application, you can have for free a dashboard with all the metrics that your application provides, and also simply adding .NET Aspire orchestrator to your existing application, it modify your application, adding OpenTelemetry to your code base. And we can see how we can add Aspire at an existing application. If you already have an application like the same that we have seen before, we have said, for example, like this one that you can see in this code, and a front-end application that asks to our backend to have data, you can add .NET. If you use, for example, Studio, just on the right click on the mouse to use your context menu and add Aspire. If you use Rider, you add host and service manually. But the operation is very simple. Once you add the code, you find this new line of code, builder.addServiceDefault. Just a couple of seconds, and we are going to discover what this means, add service default. And the second step in the project app host, that is the Aspire orchestrator in Grafana in program.cs, we find this line of code: builder, add project, and the project that you add to Aspire. Just to be honest, when you add Aspire, you can add just this just line of code like this one. Okay. And in a couple of minutes, I explain because I had some line of code extra. Okay, what is the purpose of this line add services default? Add services default add some simple service that the second project that Aspire add to your solution that you can find in this file extension CS, and this extension add configure OpenTelemetry to your application. That means it add OpenTelemetry in the same way that we had the OpenTelemetry manually in our application before .NET Aspire. Then add OpenTelemetry exporters, the same package that we had before, to expose our measurement to an external tool that able to collect this information, and we can add all the metrics that we need to measure in our application. If you run your system, your application, after you have added Aspire, this is the result. You have a dashboard, .NET Aspire dashboard here, okay, that expose the application that you add to your orchestrator, our API, this one, and the second one, the brew up, that is the front-end application, this one, because my solution has a back-end API and a front-end application. Okay, all this one is under the dashboard of Aspire, and you have here in the sidebar of your application the metrics, for example, from BrewUp from our API, and you have all the metrics of the request count and so on of your application without the need to add or to use OpenTelemetry or Grafana or Azure Monitor or everything, every tools that you prefer, but you can simply use the dashboard that Aspire provides to use to add all the information. You can have the logs, for example, or in details, you can explore what happened inside your application, and you can see also some interesting, you have all the environment that Aspire use to expose the protocol, the OTLP protocol for OpenTelemetry, but also you have a lot of fantastic environment variable that allow the Aspire orchestrator to discover from the front end your API when you move your solution from on-premises to cloud. To do this, you simply can extract app host in the way that I exposed you before, this way. You can say to Aspire that you had this project, and if you have any project, many projects with many API, you can add all the API, save the result of this operation into a variable, sales API, and then instruct your orchestrator and say to it, when you add my front-end application, in this case, Resilience Placer, this is my front-end application, before to start my front-end, please start the API, because I need the API in my application. You can find this information here with reference sales API. Okay, this is the way I inform orchestrator that before to start the front end, you need to start the API, then start the front end application. And please don't expose this API with a public address when we deploy my application into the cloud, but expose just the API, just the front end application, and keep my endpoint private and allow me as application to discover these services. So .NET Aspire resolves some important critical points when you distribute our application. Well, so far we are now are able to collect the information from our application. We are able to deploy our application in many ways. So we are ready to move away and discover the challenge that we deal when we work in a production environment. As you can see, we have many ways to distribute our application. We can distribute our application nowadays through container apps, in cloud, in a server, on premises, and so far. The engineers nowadays are overworked. They have to work, they have to spend less time fixing error and more time creating value. And we, as engineers, have to discover a way to distribute our application with distributed systems. We split our application in many services. We distribute our application distributed in the cloud. What is a distributed system before to move away? Because talking about a distributed system, or what is the purpose of application distributed system, before we need to discover what is a distributed system. A distributed system is an independent network of computers with the aim to work all together to solve a task or a problem or a task. One of the characteristics of distributed system that this is composed from many computers, or nowadays, because as I said, because we have Kubernetes, many nodes, and each of these each of these nodes has its own memory, its database, and its process capability. As you know, each microservices need to has its own database, and its microservices is able to process information, and then each node, each services in this distributed system communicate with the other through the network, sending or receiving messages and so on. And because of these characteristics, the goal of a distributed system is to increase performance, increase the fault tolerance, scalability, all this stuff that is very difficult to improve with a monolithic system, a single system. So, just because we have all these characteristics, distributed system seems to be the silver bullet of all our problems, because I highlighted some words on this definition, and so if I read again the definition of distributed system with the highlighted of some words, a distributed system is a network independent computer. Each of these computers has its own memory and processing capability, and the goal, the aim of distributed system is increased performance, fault tolerance, and scalability. Yeah, it's amazing. Nowadays, from tomorrow, I create just distributed system for all my stuff, for all my problems, because distributed system is the new silver bullet. But because there's always a but, in the 1994, a guy named Peter Deutsch, and his colleagues in some microsystems provide to us a series of fallacies. Fallacies is something that is delivered or believed or assumed to be true, but is not. So we believe that the network, for example, is reliable, but it's not reliable. We believe that the latency is zero when we send or when we receive messages, but it's not true. And same for bandwidth and the network and so on. So when you create a distributed system, we have to deal of all these fallacies. And, for example, you have to know that you cannot send as many many data as you want in your message because the bandwidth is not infinite, and this is the same of the latency. So because the latency is not zero, the way to solve the problem is okay. When I have the, the network available and when we have latency, I ask or I send many of data that I can. No, you cannot because the bandwidth is not infinite, but is finite. To fight with these fallacies, starting from 2011 in Netflix, for example, they introduced chaos engineering. To be honest, chaos engineering is older than 2011. Chaos engineering was born inside Amazon in 2003 by Jesse Robbins. Jesse Robbins was the head of the AWS factory, and he was, I don't know, volunteers in a firefighters. And he discovered that before to run inside a real fire, he has a lot of training. And during this training, he learned how to fight a fire. And so he thought that the same you can provide inside his team. If any member of their team, of his team, was able to stay calm during failure, probably it will be easy to solve the problem because each member of the team are able to stay calm and solve the problem. In 2011, Netflix, moving from on-premises service to on-cloud, introduced chaos engineering inside his chain of production. Chaos engineering, reading from principles of chaos web site, is the discipline of experimenting on a system in order to build confidence in the system capability to withstand turbulent conditions in production. Okay, that means that chaos engineering allows us to verify if our system, when it is deployed in an environment production, responds to the condition, to the production condition, in the same way that we expected that it does during our development environment or the testing environment. Some conditions are real just in production. Reproduce some condition in environment or in test in development or testing environment. To provide some condition, we need to do in production. But because we test our system in production, we need some principle before to starting with this experiment. In Netflix, for example, they have the culture of freedom responsibility. That means that each engineering can design the solution how he prefer, but instead to discover or to check to the work of each engineer, they discover that they can create a kind of resilience in the infrastructure. In fact, the name Chaos Engineering or the tools that Netflix provide, Chaos Monkey, it means that they simulate the situation of a monkey in a server room that casually disrupt or turn off or wrap some cables to discover how the system responds in this situation. So before to start an experiment, this is the name of a test in chaos engineering, you have to define a steady state. That is the state when all works fine in your system. Then, when you have a steady state, you plan an experiment. That's an hypothesis. What happens in my system if the sales API goes down, for example? Because you are working in a production environment, you need to contain the blast radius. So you have to achieve the smallest test that will teach you something about your system. Because, I repeat, you are working in production environment. So be quiet and stay easy when you run the experiment. As well as a TDD test, at the end of the experiment, you have a result, an assertion, and you can have two results. The first one, you found an issue. Okay, good job. Start to the end, to the beginning for your experiment. Prepare your code to resist to this turbulence and run the test again. You have resolved the problem or you don't find any problem, good job anyway, because you can increase, for example, the blast radius, or you can test another API, so on. There isn't a bad result. All result is a good result because or you discover a problem or you discover that your system is very robust and you can move on. This is the theory, but how can implement chaos engineering inside our application? Many of the .NET developers, probably all .NET developers, knows Polly. Polly is a famous library that we use in our .NET application, for example, to introduce circuit breaker or to introduce this kind of patterns in our application easily. In the last time, in the last years, Polly introduced some features to supporting chaos engineering inside the code.NET system. And now we discover how, for example, we can introduce chaos engineering inside our application. This is our last demo. We have our front-end application. Okay, it's a simple Blazor application that asks to the API that we saw before to give the list of the order that the customer insert in the system. So this is our page, and this is the client that we use to ask to our API the result. Okay, inside the helper, that is a class that had the services to ask to our API information, we create some different HTTP clients. When you create an HTTP client for your API, you can add, sorry, I remove this, okay. You can add, for example, circuit breaker to handle transient errors and so on. You can add, for example, some strategy when you have some errors inside your response. And at the same way, in this way, you are adding resilience to your HTTP build client. Then you can also add some chaos inside your HTTP client to simulate some problem that you can encounter during the production staging of your application. So you can add, for example, latency. Here, add a latency of 5 seconds to the request. Or I can say some fault strategy. What happens if I have an invalid operation in my API? What happens to my system? And then I can add some strategy. What happens if I have an outcome that is not the outcome that I expected from my application? Okay, all these you can have all these kind of chaos inside your .NET code during your development. Verify that your application can resist in a production environment all these systems that your system can found during the normal working option. Then I configure two different HTTP one with standard resilience, tried from so I create two different client to ask to our to our application. You can see we are going to discover how our application responds into different situations. Okay, just a moment that our systems, our demo starts, and then we can provide these in the first. Oh, sorry. Okay, sorry, I have to stop. Sorry. Yes, we need to stop the Aspire demo that we used before, and then we can run the second demo. I forgot to stop the previous demo. Now we can run the demo. Probably now will be faster than before because now the compiler of our application is already done. Okay, we have our application. We move to sales. Okay, this one is the way, the button that use a resilience HTTP client, and when I press get orders, the application run 10 calls to API, and we can see the number of the requests increase in this small window, and the get order with cows is the second one, and we discover what happened. Oh, what happened? Okay, get order. Sorry, I have to check just the address of our system before to use resilience implementation. Podcast. Okay. Yes, this is the right address. Okay. And in the sales extension service. Just a second to check the address that I can use. Probably the address is not network. Just a second. Sales. Get. Pending. V1 sales. Is the right. Because if I move to this one, get, execute. Yeah, this is the rent and localhost. V1 sales. HTTP localhost V1 sales. The operation then complete. So sorry. I don't know why, because now the address is right. Equals to HTTP V1 sales. Sorry, I try here. HTTP sales. HTTP, yeah, right, HTTP localhost 5500 V1 sales. This is the right. Why it doesn't work? I don't know. Okay, but back to the code in the meantime. In this case, because I'm using a resilience cloud, a resilience client, my application hasn't an error or a stop because it works well, because I insert also chaos, I injected also resilience in my client. In the second case, each time my API responds in the wrong way or I simulate the wrong response from my API, I have an error in my a front-end application. In this way, if an error occurs because I'm using a resilience client, I replace the wrong response with the previous response that works well, and I provide to my customer information, probably not an update information, but at least my application doesn't stop and it can continue to work. Okay, I give you all the reference of the application and the demo, so you can run the application by yourself in your on your machine. Okay, so if you want to provide chaos engineering and resilience in your application, you can use Polly. Now Polly is supported by the .NET team, so it's a very good project, and you can use this old feature to inject resilience inside our application. Of course, you can inject chaos and resilience after you have monitoring and you discover what happened in your application, and then you can create experiment to for your application. Okay, this is the last demo, and I thanks again for the sponsor. And here my bio and my reference. Please write me if you find some issue in the demo. This is the repo of the code that I used during this presentation. Thank you so much to stay with me during